We have previously discussed black holes on this channel. It is a topic of interest to both the general public and physicists. Black holes appear to hold the key to deciphering the enigmatic theory of quantum gravity. On numerous science programs, the query frequently arises, what if we already inhabit a black hole? What if the universe as a whole is a black hole? Do we live inside a black hole? Welcome back to my channel. If we reside within a black hole, would we be aware of it? We have already discussed the possibility of living around them in the distant future, but is it possible to reside inside one, as opposed to just orbiting nearby? Since this universe contains black holes, the universe itself cannot be a singular entity. What can exist on the outside of a black hole can also exist on the inside. There is no physical law that prohibits this. Event horizons can originate from a variety of sources, and there are event horizons all around us. This evening, if the sky is clear, one can gaze up and see multiple horizons, including one in the distant past. The last scattering, the cosmic microwave background radiation, is a wall of plasma that acts as a horizon for all intents and purposes. We also have the Big Bang itself, which establishes a horizon that we do not currently comprehend, as the physical laws break down at the moment of creation. In contrast, approximately 20 billion light-years away, is the cosmic horizon, through which objects fall out. They are not fall in, like into a black hole. A black hole is created when the energy density in a region is so high, that its escape velocity to the surrounding flat space, is greater than the speed of light. This is commonly referred to as mass, but mass is only one form of energy. In fact, it is energy that generates gravity. Typical dense objects, such as neutron stars and black holes, revolve so rapidly that the majority of their energy is angular momentum. For example, our galaxy contains about 3 trillion stars. If you crammed all of that into a region approximately 1 light-year across, the average density would be less dense than Earth's atmosphere, but the region's escape velocity would exceed the speed of light. As we gaze further away or further back in time, the universe becomes smaller, denser, and hotter. In fact, there was a time when the universe was so small and so dense, that it should have collapsed into a black hole. Alan Guth proposed a theory known as inflation theory to explain the phenomenon. Or better say, to mitigate the problem. The inflation theory proposes that the universe's first few moments were marked by a period of exponentially rapid expansion. The theory was devised in the early 1980s to explain several anomalies with the standard Big Bang theory, according to which the universe has expanded throughout its history. The problem with black holes is that the space behind the horizon, the so-called anti-de Sitter space, is characterized by a constant negative scalar curvature. It can be imagined like a space inside a box, a 3D space surrounded by 2D a reflective shell. Everything inside the box, inside the black hole or the bulk, can be described as a field theory, including gravity on that 2D surface. This theory is known as ADS-CFT correspondence, and it was primarily the work of the physicist Juan Maldacena. But don't expect our universe to resemble an anti-de Sitter space, because if it did, it would have solved the gravity problem by now. Unfortunately, our universe seems to be more like a de Sitter space, at least in its far future. Some physicists theorize that the observable universe is the interior of a black hole, that exists as one of possibly many, within a larger parent universe, or multiverse. Our universe contains 3-dimensional black holes with 2-dimensional event horizons. According to this reasoning, if our universe is an event horizon, it must have originated from a 4th-dimensional black hole. The problem is the singularity of a black hole, which is why we get infinities, whereas the event horizon can be calculated using current knowledge and equations. The singularity cannot be described with our current understanding of physics. Everything is encoded by the event horizon, as matter descends into the black hole. And as the black hole grows, so does the event horizon, so the surface area is just the right size to hold all the information for all the matter that has fallen inside. The interior of black holes cannot be seen from the outside due to the inability of light to flee, but the interior can see the exterior clearly. Given a very large event horizon, is it possible to establish a civilization behind a very large black hole? The answer appears to be yes. The civilization can see the outside universe perfectly well, but cannot depart. Can we find a civilization to build a case out of it? We know such a civilization, it's the humanity. We are at a center of an universe 93 billion light years across. But it seems that we live in an inside-out black hole. We cannot see outside the horizon, and the things falls out, beyond the horizon. The cosmological event horizon due to expansion of the universe, is a true event horizon, but it's opposite to a black hole. Everyone is surrounded by an expanding sphere of space, that prevents people or any events at a certain distance from ever seeing, or communicating with anyone that crosses this horizon. The light moves fast, but space between here and there, is so vast that is growing faster than the light can traverse it. A certain bearded physicist said that horizons are smooth. We pass every moment through somebody else's horizon and nothing is happening. We are still here, we are not thermalized. There is nothing special about an event horizon, except the fact that you cannot see beyond it. Black hole horizons appear smaller if you're moving toward them and larger if you're moving away, and time does not stop there. There is merely a frozen moment, where a photon could be compared to a spaceship leaving a gravity well, but not fast enough to orbit around. I must be sincere and admit that we physicists are guilty of this, as we tend to portray this subject as mysterious but cool, in order to capture the public's interest in black holes and their physics. This, in conjunction with Hollywood films, gives the public the impression that black holes are dangerous and possibly even gateways to other universes. I will give you one example. It is possible that some advanced civilization can very well live inside a black hole. They could pack a lot of stellar dense objects into a really tight orbits of each other. All these dense stellar objects can be arranged in a circle surrounding a solar system. The thing is that you cannot escape outside of this tight packed space. The escape velocity incidentally became bigger than the speed of light, but the civilization that live around its home star is inside a black hole for all intended purposes. I would expect that if we brought several dense objects, like black holes or even neutron stars, into a Klemperer rosette or similar stable orbit, we would get a big black hole, but with no center. To give you a more definitive answer, it is difficult to envision our universe existing within another universal black hole. The black hole hypothesis seems to make sense, and fill in the missing elements that scientists and experts have been pursuing for a lifetime, leading us to believe that the universe is much larger and stranger than we had previously believed. Thank you for watching.